Hi, this is Jason Molesky. In this example, we'll take a look at the sums of normal random variables. Now, Mr. Starnes likes sugar in his hot tea. From experience, he needs between 8.5 and 9 grams of sugar in a cup of tea for the drink to taste right. While making his tea one morning, Mr. Starnes adds 4 randomly selected packets of sugar. Now, let's suppose the amount of sugar in these packets follows a normal distribution with a mean of 2.17 grams and standard deviation of 0.08 grams. We'd like to know what's the probability that Mr. Starnes' tea tastes right. Well, to start with, we want to state the distribution and the values of interest. We'll let x equal the amount of sugar in a randomly selected packet. That way, x sub 1 would be the amount of sugar in the first packet, x sub 2 the amount of sugar in the second packet, and so on. Each of these random variables has a normal distribution with a mean of 2.17 grams and a standard deviation of 0.08 grams. That is, the sugar packets will vary from one to the other, but we know on average they'll have 2.17 grams, and each packet will tend to be within about 0.08 grams of that 2.17. We're interested in the total amount of sugar that Mr. Starnes puts in his tea, which is given by t equals x sub 1 plus x sub 2 plus x sub 3 plus x sub 4. He put 4 packets of sugar in, so we'll have the sum of those 4 random variables. Our goal is to find the probability that t, that total amount of sugar, is somewhere between 8.5 and 9 grams. For step 2, we note the random variable t is a sum of 4 independent normal random variables, so t will also follow a normal distribution with a mean that can be found by simply adding up the 4 means. 2.17 plus 2.17, 2.17, 2.17 for a total of 8.68 grams on average. The variance will be found by adding the variance of each of the 4 packets. Or in this case, 0.08 squared, add that up 4 times, we get 0.0256. To find the standard deviation, we simply take the square root of the variance, and we find the standard deviation of t will be 0.16. Now we want to find the probability that the total amount of sugar in Mr. Starnes' tea is between 8.5 and 9 grams. Well, to find this probability, we can standardize the boundary values and use table A. That is, we're interested in finding the probability that that total sum will be somewhere between 8.5 and 9 in that normally distributed random variable. Our z-score in this particular case on the lower bound will be 8.5 minus the mean 8.68 divided by the standard deviation, or negative 1.13. Our upper bound can also be found by subtracting 9 minus 8.68 divided by 0.16 for a z-score of 2. And finding the probability in between using table A, we find 0.8480. So that means there's roughly an 85% chance that Mr. Starnes' tea will taste right based on the information given. Now for some additional practice with sums of normal random variables, try exercise 61.